change in things. What we're looking for is the change in the value divided by the base for that value. And so in this story, we're looking at the change in nominal GDP over time divided by the base of that value, and we're going to use the 1990, the earlier year, as the base. So the difference, the change in it, would be this minus this. So this is going to be equal to 5995 minus 5803, and then we can divide that by 5803, and we'll get out a rate. And when you plug this into a calculator, it's helpful to use the parentheses, 5995 minus 5803, close parentheses, divided by 5803. And you can do that all in one phrase, and it'll give you your number. What number do we get?
0.0308.
So I got 3.3%. Is that right? 3.0? Yeah. Okay, so 3.3%. All right, and that, when you do this in the calculator, you get 0.033, right? Well, since we're talking about a percent, you just move the decimal 2 spaces over, and you get 3.3%. Now, is 3.3% growth a good number? Is that a good growth rate? Sure, that's respectable, right? At 3.3% a year, we can use what we talked about in chapter 7 as the rule of 70, right? And take 70 divided by 3.3, and what do you get? You get 21 or 22?
Yeah, about 21.
21? So at that growth rate, GDP will double every 21 years. So your quality of life is doubling every generation. Your kids will be twice as well off as you are. If you get married and have kids at age 21, which, that's probably a little bit early. So that means your kids will even be double better off than you are. Except what? Except what we're talking about here is the nominal GDP, and what we're really interested in is the real growth rate. In order to find the real growth rate, we have to control for what? Price change or inflation. So then, how can we know what the inflation rate was between 1990 and 1991? What we would want to know is how much have the prices of everyday goods and services that most consumers buy changed between 1990 and 1991. And there are numbers to help us do this. Remember, the government collects the Consumer Price Index. And so we can look at the Consumer Price Index. And in 1990, the Consumer Price Index was 130.7. But the Consumer Price Index in 1991 was 136.2. And just looking at that, does that look like a big number or a small number? Have prices changed a lot or a little? I mean, what you used to spend $130 on, now you have to spend $136 on. Can we calculate the inflation rate using these two numbers? Sure. It would be 136.2 minus 130.7 divided by 130.7, and what do you get? Does anybody want to contradict that?
I got 4%. Was 0.042.
Okay. Yeah, that's what he said. So 4.2%, right? So if inflation goes up by 4.2%, but nominal GDP goes up by 3.3%, what has actually happened?
You haven't really grown.
You've actually gotten smaller, right? Your capacity to buy things has actually gone down. Your real GDP has gone down, or at least the nation's real GDP has gone down. What else might I want to know in order to identify how your life has changed? Yes.
Your income, like, for example.
If I could get your income, that would be good. All I have is averages. What other information might I include in this to try to understand how well the average person's quality of life has changed?
The GDP capita, or
I
no?
want to get to the per capita. How do I get to per capita? I need to know the population, don't I? Okay, so then I should probably try to find what the population was in 1990 and what the population was in 1991. So the US population in 1990 was 248.7 million. The US population in 1991 was 253.5 million. So what am I going to want to do? Wash, rinse, repeat. Same thing again, right? So I can find my population growth rate by taking 253.5 minus 248.7 divided by 248.7, and what do I get?
And I got negative, or I'm tripping?
Shouldn't be negative.
Yeah, negative 5%, or.
No, you did something wrong. Try again.
I got negative 89%.
So 253.5 minus 248.7, that should be a positive number, right?
Yeah.
Yeah.
And then I'm going to divide that number by 248.7 and get a percent.
1.9.
1.9 is what I got.
Yeah.
So that's 1.9%. What does that number mean? The population grew by 1.9% that year. Does that mean that for every 100 people there were 2 new babies? That would be a lot of babies, right? If 1 out of every 50 women you knew had a baby in a year, that would be a lot of babies. What other things might be happening? Yeah, go ahead.
Immigration.
Yeah, immigration. And immigration was quite common, actually, in the early 90s. As a matter of fact, the Republicans were a very pro-immigration party at the time. You go back and watch old speeches from George Bush Sr. and Ronald Reagan at the time, and they were trying to find ways to increase immigration. There's an irony in that. Okay, so then this will dilute the nominal GDP even more, so that actually the average person is not only worse off by roughly 0.9%, but also a little bit worse off because of change in population. What we would really want to know is what the GDP per capita was. Am I right? So then I have this data from Fred, which is the Federal Reserve Board in St. Louis's website. And what they did is they report GDP per capita in constant 2012 dollars. So neither $1990 nor $1991. Let me give you the numbers for the years around that. So 1989, 1990, 1991, and 1992. GDP per capita went from $37,000, 271. Oh, by the way, this is real GDP per capita because it's in constant dollars. Up to 37,000, down to 032. Then 1991 was 36,971. And then in 1992 was 38,077. So what can you tell me? Well, from 1989 through 1990 and 1991, real GDP per capita was going down. People were being made worse off during that time period until we get to 1992 when it goes up again. Are you with me? Now you could calculate the rate of growth for every year, and this would be negative, and this would be negative, and then this would be positive. I'll leave that as an exercise for the students. Now, when real GDP per capita is